All right, so welcome to our discussion of how to factor trinomials of the simplistic form of x squared plus bx plus c. And the reason why I say the simplistic form is this is having a leading coefficient of 1, right? There's that invisible 1 in front of x squared. These are the easiest kind of trinomials to factor, and we're going to start with easy ones, and then we're going to work up to the more difficult ones and see that they really aren't that much more difficult. We can still use the same techniques to factor all of them, but being able to factor quadratics is a very important skill in a lot of different subjects. So that's why we spend a lot of time trying to learn these, and we start with the easy ones and we kind of move up from there. Okay, so if we have a trinomial, a quadratic of the form ax squared plus bx plus c, where a equals 1, which is what we have here, then the factoring technique becomes really easy. It's all about just looking for factors of 45 that either have a sum or a difference of 4. And looking for a sum or a difference is all designated by these two signs. And it really comes down to, if you think about when we factor this, it's going to eventually look like this. Every quadratic always factors to a pair of binomials, right? Two things. It's always an x. Well, it could be a constant times x, so it could be like ax and bx, right? But it's a certain number of x's, and then plus a number, or they could be minus, right? Because these could be negative numbers. Well, if these are both positive, then the resulting quadratic looks like this. It's got a positive number here and a positive number there. If they're both negative, then when you FOIL it all out, you get a negative number here. So this gives you x squared minus bx, but plus c. Because you get this negative number times a negative number, which gives you a positive number. And then if you have opposite signs, so if one of them is negative and one of them is positive, it doesn't matter which way it goes, right? If it was positive, negative, or negative, positive, it gives you the same exact thing. You get x squared plus or minus. It just depends on which number is bigger. But the big thing is this is always negative at the end. So you really want to pay attention to the details. If both of these are positive, you know that you have this situation where it's going to be x plus a number times x plus a different number. If the last one is positive and the first one is negative, right? So it's basically just like this one, but now this is negative, then you know they're both negative. And then if the last one is negative, regardless of what the first gap is, if the last one's negative, you know you have opposite signs. So this one falls into this category. We know we have opposite signs. So we're looking for factors of 45, and because they're opposite signs, one of them will be positive, one of them will be negative, and when we add them together, we're going to get a positive 4. So we need a difference of positive 4. All right, well, 45 is 9 times 5, or 3 times 15, right? Normally you just kind of list the, and it shouldn't have done a factor tree. You just list their pairs, right? So it's 3 times 15. Well, you could even do 1 times 45, and then 9 times 5. Obviously, 9 times 5 is the one that has a difference of 4. And since we want x to be positive, we want 9 to be positive and 5 to be negative, right? Because 9 minus 5 gives us 4. So minus 5 and plus 9. And that's how it factors. It's just that simple. Now, I know that you might be going, just that simple. What are you talking about? That was totally confusing. Well, it was totally confusing because I was talking about all these different things all together. So let's try and simplify it. Step 1, when we're trying to deal these things, when we're trying to factor these things, identify what the form is going to be by looking at the plus and minus signs. All right, so let's go to this one. We've got a negative here and a positive here. Well, remember that if we have a negative in the beginning and a positive in the end, we know that that's going to factor out so that we have negatives in between, because that's the only way to get a positive constant but a negative inner thing. If you just want to memorize these things, that's fine. But the way you can learn it and understand it and know why it is what it's doing it comes back to reminding yourself what happens when you multiply two binomials, right? The foiling thing, that when you multiply those through, the x piece times the x piece gives you the x squared piece. Then the x piece times the constant gives you a piece of the middle. And then when you take the constant times the x, that gives you the other piece in the middle. And those two pieces are going to get added together. And then finally, the constant times the constant is what gives you the constant term. So if I have a positive constant, the only way that's going to happen is if I have a positive number times a positive number, or a negative times a negative, because that's the only way to get a positive number. If they were opposite signs, we will always have a negative number here. Also, the only way to get a negative number in the middle is to either have both of these negatives, so that, x times, this x times this negative number gives me a negative amount of them, or in this case, w's. And then this negative number times this w gives me more negative w's for a total of negative w's. That's the only way to get that, or if they were opposite signs and the bigger number was, after the negative. But because we know that, this is positive, we know they have to be the same sign. They either have to both be positive or both be negative, and then this dictates that they're both negative. So those little things are just what helps us figure out how to factor these. You could also just simply look at 50 and ask yourself, all right, what are all the factors of 50? I got 1 and 50. I got 5 and 10. I got 2 and 25. And I think that's it. Now you got to ask yourself, are there any pairs that either add or subtract to a negative 15? Well, 1 and 50 is either 51 or 49. That doesn't work. 5 and 10 is either 5, right? 10 minus 5, or 10 plus 5 is 15. That one works. 25 minus 2 is 23. 25 plus 2 is 27. Doesn't work, right? So the only way this works is to add them both together. So they both have to be added together, but this is a negative. So that means they both have to be negative, right? Because I need to sum up to 15. So I need a negative 5 plus a negative 10 gives me negative 15. So if you don't understand how to put the negative signs there just from the shape of it, you can kind of get it from figuring out how the factors work. I think it's a lot easier to go this way and know what you're looking for. Because they're both the same sign, you're looking for the two numbers to sum to the other one, because they're basically both going to be negative, right? And if you wanted to, you could just sit here and put negatives on everything. Negative, 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 negative. And then go negative 1, negative 50, negative 51. Nope. Negative 5, negative 10, negative 15. Yep. Negative 2, negative 25, negative 27. Nope. Right? So you can do that kind of thing. Okay. Okay, so we've talked about these sign rules. Let's take a look at them specifically. So if C is positive, C being the last thing, right? Remember, this all goes back to ax squared plus bx plus c being our standard form of a quadratic. Right now, we're looking at them where a equals 1. But these rules hold for any time a is greater than 0. So as long as a is a positive number, these rules are always the same. If your c is positive, so if the constant is positive, and we have a plus symbol here, we know that these both have to be positives, whereas if c is positive and we have a minus sign here, we know they both have to be negative. So it's kind of nice. You get a pattern, right? That the factors have the two signs that match the one that's in front of b, right? The one that's in between the squared and the linear term. Because remember, this is b. Okay, so that's case 1. Case 2, this thing is negative. So we have opposite signs. And this thing is negative. We have opposite signs. The only reason why it's plus 7 here and plus 5 here is because if we have a positive 2, we know the difference of these two numbers has to be positive. So the bigger one has to be positive. And then over here, because this is a negative 2, again, we know the difference of these two numbers has to be negative. So the negative sign goes on the bigger one. Because when you FOIL them, right, when you multiply it back out, the two things that give you the middle piece, the two things that give you the linear term is negative 7 times x and then x times positive 5. So you get a 5x plus a negative 7x gives you negative 2x. Whereas in this case, you get a negative 5x plus a 7x positive 2x, right? So that's always the case when you're foiling these things out. So that's why the patterns hold the way they hold. So once you know those two basic cases, and it all comes down to looking at the sign of your constant. If the constant is positive, then you're going to have same signs, and if the constant is negative, you're going to have opposite signs. And then when you have same signs, you know that they're either both positive because this one's positive, or they're both negative because this one's negative. And once you know that, you can tackle these things and go from it. Well, the first thing you got to do is write these things in proper form, right? So this becomes p squared minus 8p minus 48. Okay, now it's in proper form. I can see that this is negative, so I'm going to have opposite signs. And this is negative, so I know my difference needs to, the bigger number has to have the negative on it. So it's going to factor out with a p and a p, because that's the only way to get p squared. And one's going to be positive, one's going to be negative, and the bigger number is going to go here. So then I go up here and go, okay, factors of 48. I got 1 and 48. I got 2 and 24, 3 and 16, 4 and 12, 6 and 8, and that's 8. That's it. Then they repeat, right? The next bigger number would be 8 and 6, blah, and I don't need to repeat them. Okay, so I'm looking for a difference, right? Because one's going to be positive, one's going to be negative. I need a difference of 8. Well, that's not going to work. That's not going to work. That's not going to work. There we go. 4 and 12. And because we need it to be negative 8, the bigger number goes here, smaller number goes here. All right, let's look at the next one. Again, I'm going to put it in standard form. Put the first term has to be the biggest power, right? And then it goes down from there. So the next one is the next largest and then down to the smallest. First thing you always want to do when you're trying to factor polynomials is factor out the greatest common factor. What do they all have in common? Well, they all have a 10 and they all have a t. So what am I left with? T squared minus 3t minus 4. And I recognize, what I'm left with is a perfect little quadratic. And I'm going to deal with just the quadratic. I know that this piece, right, just this piece, not the whole thing. I'll bring the 10t back in when I'm done because I don't need my brain to be thinking about extra crap. I know this piece, again, is going to give me two binomials. They're going to have to be t and t because that's the only way to get t squared. And then because this is a negative, again, I've got opposite signs. And because this is a negative, the bigger number is going to go here. So I look at 4, right, which is pretty easy. It's only 1 and 4 or 2 and 2. And because they're opposite signs, again, I'm looking for differences because one of them is going to give me a positive number of t's. One of them is going to give me a negative amounts of t's. So the difference between those two has to result in negative 3, which I think we can all see is pretty obviously 1 and 4. So I put a 1 here and a 4 here, and I check it. This would be t minus 4t, which would be negative 3t. And then all I got to do is slap the 10t on it, and there it is all factored out. All right, a couple more examples. Now we've got that pesky minus in front of us. So the first thing we want to do is take it out and make it a squared minus 6a plus 8. And we couldn't factor anything else out, right, because they didn't have anything in common. But now that I've done that, we can now concentrate on just this piece. Ignore the minus 1. If you want, you can throw it out here. Just know that it's going to be there eventually. It's a positive, so we know they're the same sign, and we know that they're negative because it's a negative here. So we have a negative, a negative. We know we have an a and an a, and now it's factors of 8 that add to negative 6, but they really add to 6 because they're both going to be negative. Well, 8 is 1 and 8. That would give me 9. 2 and 4. That gives me 6. 2 and 4. Once again, we do the same thing with this. We factor out our greatest common factor, which in this case is a negative 2. There's a C, there's a C. Nope. There's a D, there's a D. Nope. There's nothing else there that I can factor out, right? So I'm left with C squared plus 11CD minus 60d squared. Okay, this one is different because it's got this d going along for the ride, but the idea is still the same. We still have a quadratic as far as the c's are concerned, right? Because we've got a c squared here, a term with just a c in it, and then a term with no c's in it whatsoever. So it still fits our quadratic form. It's just you want to think about it. In this case, we could really kind of write it like this. C squared plus 11dc minus 60d squared. And think of 11d as being the b, right? Because remember, it's ax squared plus bx plus c. And in this case, a equals 1. So here's a. And of course, now our x's are c's instead of x's. But this is the b, and then this whole thing is c. Well, we've got a negative and a positive, so we know it's going to be opposite signs. We know the only way to get c squared is c and c. And now we got to figure out factors of 60d squared that give us 11d, right? If we write it this way, it reminds us that we're looking for 11d. So 60d squared. So if we're going to get 11d, we're going to have a certain number of d's plus a certain other amount of d's. So everything is basically going to factor to a d and a d. So it's going to be like 1d and 60d, right? 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't work, 8 doesn't work, 9 doesn't work, and we're back to 10. So those are all my factors. Okay, so again, because we have opposite signs, we know we're looking for a difference of 11. So 60 minus 1, 59, right? 1 minus 60, negative 59, doesn't matter, right? So you only have to do it in one direction. 30 minus 2, 28, nope. This one's 17, nope. Ooh, 11, right here. 4 and 15 gives me 11. I need positive 11, so the bigger one goes here. So it's 15d, and over here, 4d. Because remember, these all had d's on them. I was just too lazy to write them all down. Because obviously 60d squared doesn't factor to 4 times 15. It factors to 4d times 15d. Now you might be saying, well, couldn't it also be 4 times 15d squared? Yes, but that wouldn't work because then the middle pieces wouldn't be the same, right? If this didn't have a d and this had a d squared, then when you multiplied these two together, you would just get 15c. And when you multiplied these two together, you get negative 4cd squared, and those things wouldn't combine. You need them to be able to combine, right? This gives us 15dc. This gives us negative 4dc. We can add those together and get a certain amount of dc's. All right, one last example. We're back to the simpler version, right, where we just don't have to worry about that second variable. It's nothing, we can't factor anything out. But we know from its format, because this is a positive, they're the same sign. And because this is a negative, they're both negative, right? So now we're looking for factors of 14. Well, we got 1 and 14, 2 and 7, and that's it. And you're thinking, oh, well, it's 14 and 1, because 14 minus 1 works. Nope, it doesn't, because remember, they both have to be the same sign in order to give you a positive 14, because then that'd be negative 14 times negative 1 gives you a positive 14. But if we did this, we would have negative 14x, negative another x. That'd be negative 15x, which doesn't match, and this doesn't factor. So basically just pointing out that not everything in the world factors. But by using this simple technique of showing the factors of c, remember c is your constant, and then basically checking to see if any of the pairs work. If none of the pairs work, we know it doesn't factor. At least it doesn't factor with whole numbers. The next thing you would have to try would be the quadratic equation. But that's for another lesson. This is all I've got for you guys for today.